Hello everyone. Here is a very basic introduction to probability. Stuff happens. We don't know what will happen. Probability is a mathematical model to quantify our certainty about what will happen. Let's look more closely at this definition. Mathematical means, well, that math will be involved. There could be definitions, new symbols, formulas, things like that. Method means that this is a process. My old mentor John Erdman used to tell me that math isn't something you know, it's something you do. Quantify means that the result of this mathematical method will be a number. And certainty is how sure we are of some event taking place. So, let's look at one way to calculate probability, what's called the classical or theoretical method. This method won't work all of the time, but when it does, it's pretty simple to model, meaning that the calculation of the probability is pretty simple arithmetic. Theoretical probability requires just one thing. That is, that each possible outcome must have the same likelihood of occurring. For example, let's think of flipping a coin. If I were to ask you which is more likely, that it comes up heads or that it comes up tails, you'd think I was crazy. They both have the exact same likelihood. Or another example, rolling a single die. Die here is the singular of the word dice. If I roll a six-sided die, which side is most likely to end up face up? Well, obviously all six sides have the same likelihood. And one more example. If I shuffle up a deck of cards and then draw off the top card, which card is the most likely? Well, that's easy. All the cards have the same likelihood. But here's an example of a situation that doesn't have the same likelihood for all the different events. Suppose today is the first day of June and we are in Boise, Idaho. Which is more likely? That it's sunny? That it's rainy? That it's snowy? Or that we have a tornado? It doesn't take much knowledge of meteorology to realize that these different events have very different likelihoods. So, if we have a situation in which all the possible outcomes have the same likelihood of occurrence, how can we calculate the probability of some particular event? Here's the formula. The probability of an event, you can see, is a fraction. You divide the number of ways the event can happen by the number of ways that anything can happen. Now, this doesn't look very mathy, but we can make it look a bit more formulaic by introducing some common notation. So, let's be abstract and refer to our event by the capital letter A. And instead of writing out the word probability, let's just use the letter P. Then the probability of event A occurring is written as P of A. We can also adjust our formula to use this notation, divide the number of ways A could happen by the number of ways anything could happen. And that's really all there is to it. Let's look at an example to go a little deeper into probability. Suppose I flip a coin. But wait, that's not actually what a probability textbook would say. First of all, we need to specify that this is a fair coin, not one that has been gimmicked to produce a certain result more often. And secondly, for whatever weird reason, the books never talk about flipping a coin. They always talk about tossing a coin. That seems wrong to me. Tossing a coin is what the mythical George Washington did when he threw a silver dollar across the Potomac River back in the day. But that doesn't feel like what I do when I flip a coin, but that's what all the books say. So let's start over. Suppose I toss a fair coin. That will keep the textbook authors happy. What is the probability that the coin will land with the heads side facing up? Now you know, before we do any sort of calculation, we need to think about the situation and make sure that it satisfies the requirements imposed by our mathematical model. Namely, we have to think of all the possible outcomes and convince ourselves that the likelihood of each outcome is the same as the likelihood of any other outcome. In this situation, the possible outcomes are that the coin could land with its head side facing up, or it could land with its tail side facing up. This feels way too formal. Most people just call these outcomes heads and tails instead of landing with the head side facing up. If you think about it, I'm sure you'll realize that the two outcomes have the same likelihood of occurring. Well, we even discussed this before. So it is okay for us to use the theoretical probability formula in this situation. So here it is. We'll define the event A as a fair coin lands head up after being tossed, and we can write out our formula as P of A. It's a fraction. In the numerator is the number of ways a coin can land head side up divided by the number of ways a coin can land. Well, it seems to me there's only one side of the coin that has a head on it. So the top of our fraction, the numerator, if you want the mathy word for it, is 1. And there are two sides on the coin, so the bottom of our fraction, the denominator, must be 2. This calculation isn't very tricky at all, as promised. The probability of getting heads on a fair toss is 1/2. Now, you might wonder about the format of this answer, so let's deal with that question here. In my math classes, I have these sayings of mine that I call my silly slogans. They're truths, or maybe truisms, that remind us of what's going on. Little signposts along the way to help us remember what to do and how to do it. One of my silly slogans is, fractions are our friends. Your mileage may differ. Depending on how you were taught, you might have struggled with fractions in school. But the truth is that fractions are pretty easy to work with, usually easier than doing similar operations in other formats. Now, you, of course, might be thinking of things like common denominators and other fraction rules that make things a little more complicated than my silly slogan implies. Well, I do have good news for you. In this class, we will never be required to reduce any fraction to lowest terms. In fact, for our purposes, keeping the fractions unreduced will make it easier for us to compare them to each other, and thus to understand what the number, that is, the quantification that is the result of a probability calculation, actually means. So, we are perfectly happy with saying the probability of heads is 1/2. But just so you know, there are two other very common formats to express probabilities. One format is as a decimal, and the easiest way to get a decimal is just to use a calculator and divide the top by the bottom. So 1/2 is 1 divided by 2, and our calculator says that's equal to 0.5, and there's our probability expressed as a decimal. If you were in a statistics class, then the decimal equivalent would be the one used most often. But for our class, we're perfectly happy with a fraction, even if the fraction is not reduced. And then there's one more way to express a probability, and that's as a percent. Now, hold on there, sit back down. I didn't mean to startle you. I know that percents are sometimes considered very difficult by students in math classes. The reason for that is that those students haven't heard my explanation, which unfortunately, or maybe fortunately, depending on your point of view, we don't have time for in this class. Take one of my other classes if you want to hear it, or ask me in my office hours, or drop me an email. In this class, the only thing you need to know about percents is that you can always convert a decimal to a percent by multiplying the decimal by 100. So, in this situation, we grab a calculator again and multiply our 0.5 by 100, and we get 50. So we can say the probability of heads is 50%. Expressing a probability as a percent is common in several situations. For one, the TV weather reporter never says the chance of rain tomorrow is 0.5. They always say there's a 50% chance of rain tomorrow. Also, most ordinary people are more comfortable with probabilities expressed as percents. So if your grandmother asks you the probability of a coin toss resulting in heads, you should tell her 50% as well, not 0.5 or 1/2. But in this class, we are fine with fractions. They're quick, it's our original answer. They're easy, they're intuitive. We don't need any extra steps to get our result. Once we have determined how many ways the event can happen, that's our numerator, and how many ways that anything can happen, that's our denominator, we're essentially done. Which brings us to another point. Since probability is a mathematical activity, it can't perfectly mimic the real world. Wow, this is one reason we call these things mathematical models. They model the world, but some details are, of course, lost. This is because the mathematical model is an abstraction of reality. For example, I said that there were only two ways the coin could land. Heads up, that's one way, or tails up, that's another way. But in fact, a coin could also land on its edge, which would be a third way. I expect this would be a very rare occurrence, but it could happen. Even so, because this is a mathematical model, an abstraction, we are ignoring this possibility when we say there are just two ways the coin could land. But wait a second, just two ways? Well, yeah, actually there are many different things that could happen. Maybe when I flip the coin, a hawk suddenly flies by and snatches it out of the air with its talons, and, well, that's a fourth way. Or maybe a wedding celebrant shooting a gun into the air in jubilation accidentally blasts the coin out of the sky. Or maybe the coin bounces a few times and then rolls into a sewer drain and gets swept away by the rushing water. That would be a sixth way. Or maybe anyway, you get the idea. You can see that there are lots and lots of possibilities, and we are ignoring all of them in our mathematical model because it's an abstraction of the event. So, to sum up, if we have a situation where all the possible outcomes have the same likelihood, then we can use the classical or theoretical model of probability. The formula for classical probability says that the probability of an event is a fraction. In the numerator, the number of ways the event can happen, divided by the number of ways anything can happen. And the answer to this division will always be a fraction, and we're happy leaving it in that form. Our answer isn't perfect because we're using a mathematical model and abstracting the situation in order to calculate the certainty of the event. But even with its imperfections, it does tell us more than we knew before we used it. Thanks for watching. Please holler if you have any questions.